हाँ, ये वो निशान लेके आया खाकरवाड़ी का चूहा खाकरवाड़ी नहीं बस
मम्मी 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 यहाँ गेट बंद कर दिया। Hello, hello. Am I audible to you? Animus Sunil? Hello.
Yes, you are audible.
Ji. Have you done the week 3, week 4 recordings, the lectures given in
No,
recordings?
I was trying to, you have shared those recording, but whenever I am trying to log into those recordings, I
Hmm.
do not, I just get an Excel sheet and no recording whatsoever. I tried
Okay.
in week 1, week 2, and after the third week, I didn't try. So I'm
Okay.
trying to do the assignments also on my own only. So that's it.
Okay.
Yeah.
Let me show you how to like navigate into those video lectures which are uploaded by in on Swam portal.
Oh,
So
sure, sure. Right. Thank you. Yeah.
yeah. Yes, you were able to access this sheet, right?
Yes, I can. Yeah.
Yeah. So you just go on this link.
Okay.
Uh, and you try to open it in incognito window.
Okay. Yeah.
Once you go there,
Mm.
this is, for me it's already login, so let me log out first. So you will be redirected to this sort of page. So you try to log in here.
Okay.
You must have created some user ID or name, right?
Yes, yes, yes.
So if
And
you
I
put
can do the Gmail. Yeah, yeah.
yeah, if you put it here, if it is not login from this window which is given here, you go
Okay.
to Google.
Yeah. Yeah, that's what I do.
Yeah, and through Google you try to put your email and password which is given, so you will be redirected to these courses.
Mm-hmm. Yeah.
Okay, here you can attend video lectures which is taken by sir. Like
Yeah,
for
yeah,
week,
that's what I'm following. I'm following those. I just
yeah,
wanted to see the video recording of these, problem
problem
solving sessions.
problem solver.
Yeah,
Okay,
yeah, yeah, yeah.
from this sheet itself, the last link which is given, no? This last link, you
Okay.
just open this last link.
Okay. Oh, okay, okay, okay. Right.
You will be
Got it.
redirected to this Excel sheet.
To this Excel sheet. Yes, yes.
So here you can access the recordings and the files.
Yeah, but
Here
then
the
it takes me to some drive. I don't know.
yeah, Drive, those PPTs are uploaded in Drive. So these are the 3 weeks PDF.
Mm-hmm.
So if like
Mm-hmm.
the last week video what we did is uploaded here in PDF format. The presentation we did. So today we will do one problem also which was left in the week 3. One problem was left. It was time was not sufficient to cover all the questions. So two problems actually, two problems are left. So we will cover it today.
Mm-hmm.
And so from here you can download the sample problems and solutions which we have discussed in the class,
Oh,
and
okay,
these
okay.
are
So
video
today,
notes.
yeah, you
Yeah.
are right. So today you are going to discuss week four problem solutions or for the week three, like
Mm,
in the current
both.
session you discussed the last assignment problems, no?
Yeah, yeah. I will discuss four also, but
Okay, okay.
in
Yeah.
week three, two problems were like unsolved. Uh,
Okay, okay.
we were not able to
Okay,
solve
okay.
all the problems within 2 hours. So two
Yeah.
major, like
So
it's a good good
mm,
numerical. So
yes, yes, yes. So I'm a chemist actually, and while registering for this course, I didn't realize that it is meant for environmental engineers. So that's
okay,
why I'm little bit struggling with the problem part of it. Anyway, I'm making an attempt and doing my bit. So I thought I will just log in today and attend the session. As
okay,
I am also a working professional, so by the time I come home, I
okay, ma'am.
either forget or sometimes I just don't log in even if I do remember. So I was free today. I thought I would log in and attend your session.
No issue, ma'am. If you have
Yeah.
any problem, you can just ask during the session, like anytime.
Okay.
If I
Okay.
am able to solve it at that instant, I will. Otherwise, I will revert back to you in next week.
Okay. Right. Thank you so much. Right. Thank you.
Yeah. Um, today, like in last class, if you want a little bit of overview of the previous class, I can start with that, or directly we can go to the problem.
Last session, there was a problem based on sir had given that 15 grams per meter cube the contaminant is present, and then
Okay.
he had given the trench size this much
Okay.
meter long, wide, and deep.
Volume. Yeah,
So
yeah, volume.
we were supposed to calculate for that whole part. Am I right?
Okay.
The contaminant concentration for the
Yeah.
whole of the trench, and then go to the next part of the problem. Am I right?
Yeah.
Because we were supposed to calculate the retardation factor.
Yeah, yeah, yeah. So those problems we did in last class. So I will give you the overview of a similar kind of problem
Sure,
so that
sure, right.
yeah. So basically during the class I discussed like three types of mechanisms where one was when the contaminant is totally absorbed. Sorry, totally dissolved in the system.
Yeah.
And the second was dissolved and adsorbed, and third was dissolved, absorbed,
Absorbed
and
and third was absorbed in NaPl,
yeah,
right?
yeah, yeah. So
Yeah.
those based on those three scenarios, he developed three different equations for
Mm-hmm.
the estimation of mass as well as the retardation factor.
Yes, yes, yes.
Yeah. So
So the
same,
concentration ratio, when we are calculating the concentration ratio, right?
yeah,
Which is kind of partition between NaPl and the total concentration, right?
okay.
That total concentration we have to take into account 15 centimeter cube, I mean 15 meter cube, or for the whole the trench. What we are supposed to take into account for the
So
whole
this
trench? Yeah?
this is the total volume. Uh, like the dimension which is given here, like specifically for
Hmm.
this problem, we have given length, breadth, and depth. So
Ah,
we
ah, ah,
now we know the volume of the soil. So now,
ah,
but
ah.
we are concerned with the water present in the soil because
Yes.
in aquifers,
Yeah.
yeah,
Ah,
groundwater exists in pores. So
yes. Yes.
there is something called porosity. You aware with the term porosity?
Uh, I just went through those slides only.
No
So
issue,
if
ma'am.
you can,
No
yeah.
issue, ma'am. Ma'am. Uh, So actually, when we draw water from ground, so like water is not like underground. It's not like river. It's actually stored in
Mm-hmm.
the pores inside soil. So
Mm-hmm.
we can from this volume, the dimension which is given, so it's like a box in which soil is filled. So it's a 200-meter, 50-meter, and 15-meter deep box in which soil is filled, and soil has some pores. So in those pores, water is filled. So if I want to calculate the amount of water which is filled there, so what I will do, I will calculate the volume of the whole system and I will multiply it with porosity. So now how multiplying it with porosity will give the volume of the pores. So porosity is basically volume of voids divided by total volume of system. So
Okay.
if you multiply it by the total volume, which is the dimensions are given, so you will automatically get the volume of the pores. So
Okay.
now,
And they had mentioned that it is only 3% occupied, like that in one of the
yeah.
problems.
Yeah. So, like what sir discussed, three different types of scenarios where the contaminant is in dissolved form, and in some situation it is in adsorbed form and NaPl. So some situation it is given that only 1% in like in extension of this question, which you can see here, like only
Hmm.
1% of pore. NaPl occupies only 1% of the pores. So that
Yeah.
also we can determine, right? If we
Hmm.
know the total pore volume, if we
Hmm.
multiply it with how much space is occupying,
One,
we can,
yeah,
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 we
yeah,
will get.
yeah,
So
exactly. 1/100. Yeah. Hmm.
yeah, so
Or
that
0.01 we multiply, no? Hmm.
yeah, you can
Hmm.
based on if we are calculating for NaPl, we can just multiply it by 0.01, and for other things like for dissolved system, like three different phases are existing parallelly. So for
Hmm.
dissolved part, we can multiply it with 0.99 and
Hmm.
for NaPl zero point 0.0. So
Okay,
so
okay,
this
right.
yeah, let's go through
Hmm.
this question numbers 6 and 7. Then we'll go to the problem which was not done in last class. So this
Okay.
is a basic problem which is given where site is contaminated with TCE, and
Hmm.
we are given with the dimension of the particular area where TCE contamination is there. So 200-meter by
Hmm.
50-meter wide, 50-meter deep,
Ah,
and
yes. Hmm.
yeah,
Hmm.
and organic matter fraction is given as 2%, and soil
Hmm.
water partition coefficient is given.
Hmm.
Porosity is given. Porosity is zero point 0.4. That means the volume of pores is only 40% of the total volume,
Hmm. Hmm.
and bulk density is
So,
given for the soil,
hmm.
and the question is asking for the partition coefficient. So during the discussion, uh, when I was discussing dissolved and absorbed system where we have to calculate like if some
Uh-huh.
amount of contaminant is adsorbed on the soil. So
Hmm.
when there is a rebound, when you extract water, there will be new water will replace the older pore spaces, and the contaminant on soil will come into the water
Yes.
to create a
Ah,
new
yeah.
equilibrium. So
Yes.
so
Hmm.
for that,
That part I understood. Hmm.
yeah. So Q value we calculate, we came up with a formula which was called partition coefficient into concentration. So partition coefficient calculation formula was like multiplication of organic matter fraction as well as soil partition coefficient. So these two values are given to us, so we can
Hmm.
calculate Kp value from here.
Yes. Yes.
So we
Hmm.
once we have Kp value, we can go for retardation factor calculation, because in
Hmm.
this system it is a dissolved and adsorbed system. So we came up with a formula which is like this: 1 plus
Hmm.
partition coefficient, then bulk density of the soil as divided by porosity. So
Hmm.
we calculate retardation factor. So this is basically one part of the question which where we have some information and is a case two situation. So
Hmm.
if we go further, here it is telling to calculate retardation factor, but in this question it is the extension. This it is case three where NaPl is also present.
Hmm. Yeah.
So in this situation, we have a dissolved, adsorbed, and NaPl system.
Hmm.
Hmm. So यहाँ पे here it is given that 1% pore space is occupied by NaPl, and the zone is contaminated with TCE, which is the extension of previous question. It was given that
Hmm.
TCE is the dissolved and adsorbed part, and we also have NaPl. So some
Hmm.
information regarding that is also given. So TCE aqueous concentration is given, and density of NaPl is given.
हाँ वो किस लिए दिया है? Why the density of
Yeah,
NaPl? What? How we are going to use that?
yeah. One second. So, if we go to the formula which we derived in the class, so we had the formula for mass, total mass as for the case 3 scenario, 1
Hmm.
minus S, which was
Oh,
basically pore
yeah, yeah.
space into
Hmm.
porosity, volume of the system, and the concentration.
Hmm. Hmm.
This is the for the dissolved part. Then we have similarly for the adsorbed part.
Yeah. So I could, place the value of everything here,
Yeah,
but I just had a doubt. This concentration we have to take into account for the whole trench, right?
20 gram calculation. No? 20 gram when you go for the second term, no, this adsorbed part calculation.
Uh,
So there this 20 this 20 gram per meter cube जो density दे रखा है sorry third part
hmm, hmm.
second part calculation it will be required. So
Achha.
let me solve them.
Yeah, sure, sure.
Yeah. This is the pore volume which is occupied by NaPl. So in this pore space, there won't be any water. So we won't consider that part in the uh, dissolved part. So this is basically case when we are considering TCA where it is dissolved in water. So that water won't be there in those space. So we won't consider that volume into porosity into volume of the system. Volume of the system was coming around 15 10 cube power 4 meter cube,
Hmm.
and then we had concentration of around 0.02 kg per meter cube
Hmm.
because it is TCE concentration. So this value which is given here, TCE concentration,
Mm.
this will used here. It wasn't used previously in the previous question because we weren't calculating empty value. So concentration was cancelled out because we were dividing it with the mass which was present
Okay.
in the soil. So it wasn't used there. But here, because we need to calculate mass also
Mm.
in the next problem. Here we are calculating retardation factor, but in the next problem we need to calculate total mass of the TCA
Yes,
system.
yes.
So we will require the M value and we will require the concentration also. So if here we put 0.02 kg per meter cube, so there will this if we solve it will be around 1188 only
Okay.
this specific term. Similarly, if we solve for the this second term, it will be around 1 second. If we solve for the second term, it will be around. So we already know the KP value from the previous problem we did, right? Uh,
Mm.
we can directly use this KP value, which is given here. It's 3 liters per. So let me convert it to meter cube. So it will be around 3 into 10 to the power minus 3 meter cube per kg. Because Q value we can uh, get this formula as Kp Q value if we specifically if we see Kp into C. So it will
Mm.
be this Q values. So here Kp specifically is this, and then we will the concentration value will be again this same
0.02.
yeah 0.02. Then we will have the density value of the soil, which will be 1.65, which is given in the previous question, and then the volume of the system, which is 15 into 10 to the power in meter cube, but
4.
if we are taking it in liters, because
Mm.
so it will be 7.
Okay.
Because we are using it 1.65, I think with this value 1.65 is given in kg per liter. So if we directly put it in terms of liter, it will cancel out. So this, if we solve this term, which is the second term, the adsorbed part, it will come out to be around 1485.
Okay.
14850. And this third term, which is it will be again 0.01, because only it because this is for NaPl, only 1% space is occupied. And porosity is 0.4. Volume is again 15. and for 4. Here all the terms will be in meter cube, so I'm using the meter cube value. And then this density is given. So this density is for NaPl. So here we will use the NaPl density. So 1464 and fraction is will use directly as 1. So if we solve this term, we will get value around, which is basically this 878400. If we add all these three values, we will get the total empty value, mass of the contaminant value, which will be around 894.438. So this value is in tons.
Mm.
Yeah. So now once we have empty value, so retardation factor also we from the what we learned was the total mass of the contaminant divided by mass of contaminated water. So if we divide this empty value, we can directly calculate the retardation factor as total will be 894. Point 43 divided by the mass in the water was the first value. This, so this value we already know it is 1188. If we divide it by 1188, we will get retardation factor, which will be around 752.89.
Mhm.
Yeah. So by this, like we retardation factor also, the new retardation factor we also calculated 752.89, and the total mass of contaminant in tons, both value. Yeah.
Mhm.
So what in this, like, still there's it's not clear, or now?
No, it is clear. Now it is clear. Yeah. I'll try to do it on my own again and probably I'll get it better.
Okay. Okay, let me switch to slide week 4 slide.
Yeah. Just a small request. Can you suggest any book for referring to this problem solving, which I can refer to if it is online or if I can get it from my library or something?
Mm, I know the books, but I was not able to find numerical problems in books. So I will suggest you next week probably,
Oh,
specifically
sure.
for
Thank
numerical
you.
problems.
Yeah, thank you so much.
We'll start with week 4. A few numerical questions and few multiple choice questions. So we'll do them. Is it okay? Like how you want to proceed? You take them some time to solve the problem and then we'll discuss.
I think you can solve those problems, no problem. I mean, I will follow.
Initially, 1 2 problems are theoretical problems only based on the lecture 4 given by sir. So initially, the first problem is select the site condition where PRB as a method for remediation can be applicable. So sir discussed basically three methods where uh, if we use PRB, uh, it can be like applied on in those scenarios. So you take some time and you like read the options and come up with some answers. Then we will discuss. Like if I want to apply PRB system, in what scenarios it can be applicable. Like there are a few problems like unclear location of the source, high solubility of contaminants, large volume of contaminated sites, uh, or fast contaminant
So,
release from the source. Like
is it unclear location of the source because you don't know what size the plume is and from where the plume is extending into the groundwater source?
yeah, true, true.
Is that right?
Yeah, it's correct. Mostly in case of unclear location of the source, we use PR. Second is select the possible mechanism for the treatment of uranium by elemental iron. So in class, I discussed the method for uh, treatment of uranium through iron. So basically, there was few system it is only sorption, and few system uh, redox reaction is also possible. So based on that, specifically for uranium, also discussed one mechanism. So based on that, this question was there.
I am yet to come to that, but I just guess that it could be reductive precipitation because elemental iron will be going into oxidized form. This is zero valence. From zero valence, probably it will go to ferrous or ferric hydroxide form.
Hmm.
So either co-precipitation with iron oxides or reductive precipitation, I guess.
Okay. So in some situations, like only specific mechanism is applicable. In case of uranium, all three were happening simultaneously. There was reductive precipitation also, sorption also, and co-precipitation also.
Okay, yeah, no, not necessarily that all the iron is
Oh,
in +2 state. It could be +3 also. So makes
yeah,
sense.
yeah.
But then aren't we supposed to select one of the three? I mean, or
In
is it?
this, it could be multiple correct also.
Achha.
Yeah. Because in real time, if we doing element like uranium removal by iron, all three of these mechanisms are opposite. Yeah, this is a simple problem. We can try oxidation state calculation.
This is +6.
Yeah,
Chromium in dichromate is
yeah,
+6.
yeah. Uh, Nirupa, am I audible to you? Uh, do you want me to calculate the oxidation state for this?
No, sir.
Nirupa,
Oh,
okay.
yeah, you're audible.
Do you want me to calculate the oxidation state for this, or is okay?
Uh, and not required, sir.
Let's continue. So this is a numerical problem which, uh, like in week 4, sir discussed regarding the design of PRP. So basically, we are given to determine the number of, we have to determine the HRP basically, how much hours required for the remediation of TC plume using a nanoscale zero, we are using NZVI. Batch test was performed between designing the actual PRP. So, sir discussed like for the calculation of K value, we performed a batch test where we plot concentration versus time graph to calculate the K value. So based on that, there was some value, some initial concentration and final concentration are given in the problem, and we, assuming it to be pseudo first order reaction, and rate constant is given. So based on that, we need to calculate T value. So you can try to calculate the T value on ohms, then we will do the problem. So basically, sir discussed the variation of the concentration with distance and with time, and we considered we did a mass balance, and we came up with a equation for steady, specifically for steady state. So that equation, that simplified equation will be used for the calculation of this. So once you try, then I will try to recreate the derivation, and then we will like do the problem itself.
I'm sorry, I'll be requiring help here, so I
No,
will
no,
just wait for you to continue.
okay. Nirupa, would you like to try, or
We can go for derivations.
so uh, if we consider a particular area where uh, contamination is there, so we are calculating like accumulation in that particular region, in this particular volume. So if we consider the system, we will consider how much mass is present inside the system, or change of mass with respect to time, or accumulation, as how much mass is coming inside the system, how much is leaving the system, and how much if there is some reaction happening inside the system which is leading to the formation of that compound, or uh, the consumption of that compound. So by that we can calculate like how much mass is accumulated inside the system. So that mass balance we have to write. So if I take it as variation, like at certain instant, or with respect to time, how mass is varying, I can put it as the mass which is entering the system. So if the mass is entering the system, we will consider the sign to be positive because it's adding to the system, and how much mass is at and is exiting the system. going outside the system, or plus minus if there is some formation or consumption of that particular substance inside the system. So we will consider it as, and we will put plus or minus sign based on if it is the formation or the consumption of the particular ones. So if we see this unit of this is basically we take mass unit to be kg and time as per second. So we're dealing with mass per second. Based on that, this the unit of this particular term will be also be same. So if I want to like further bifurcate into simpler terms, if I want to calculate how much mass is entering inside the system, so if what is entering this box, so it must have some discharge, right? So how if water is entering, what is the discharge of that water? And if I'm looking for certain contaminant or certain compound which is entering the system, which has some concentration in this water, which has Q discharge, which has Q flow, which is entering the system. So that I will assume as CI rather. So this value will basically give us how much mass is entering per unit time inside the system, because Q will be volume per unit time and concentration will be mass, and you can take it in kgs per liter. So, or we can say it is in terms of volume, right? So this term and this term will cancel out. So we will basically have kg per unit time. So how much mass is entering inside the system, right? If we multiply the discharge and concentration at the inlet end. Similarly, we can also calculate for mass out, because there will be some low Q and there will be some concentration CO. It will be, if we have PRB, it will be comparatively low because it's coming up after treatment. So if we can like, write this equation in another form such as in like QI CI minus Q out. And the last term, which represent the formation or the consumption of the particular compound within inside the system. So that we can represent as volume of the system into rate of formation minus rate of loss. This expansion of the thing which we wrote here will basically give us the how much accumulation of mass in particular system. Right? But this equation basically gives us the variation with respect to time. Like if this is a river and the example sir took was like Roorkee to Haridwar, there is flow. If we are seeing the variation from this point to this point, this is basically variation with respect to distance. But if we stand here at this particular point, and if we are measuring concentration at T1 and T2, so if we are measuring here only two different times, this will be the variation with respect to time. But this variation, this from one point to other point, is variation with respect to distance. So that factor we need to, because concentration will also vary with respect to distance. So we need to incorporate that also. So after that, if we incorporate the variation with respect to distance, so that we let me DC by dx. So this basically represents the variation with respect to distance. The variation of concentration, if we take the river from Roorkee to Haridwar, so variation of concentration with respect to time. This I'm basically representing this variation, and then we will have a diffusion term. But if we are taking surface water, diffusion won't be that prominent. Advection will be prominent because contaminant is traveling with flow. It's majorly not happening because of the concentration gradient. It's majorly happening because there's flow in this direction of water, and because of that, so there will be a diffusion term, which but it won't be uh, the value for that term won't be that large, so it will become insignificant in this equation. So we'll neglect that term and will directly go to the volume part. The this term. So here, if we assume steady state, so there it's at steady state won't be any variation with respect to time. So at steady state, this variation will become zero. So it will be only u dc by dx. Now this is the velocity of the flow, and this is distance variation with distance. If we take this term here, x by u, this is basically will give us the theta, which basically represents the time required, the HRT of the system. So x value, which gives the distance traveled divided by the velocity which is given. So it will give us the HRT of the system, time required, time in which the water or contaminant traveling within the boundary from inlet to outlet. So if we take it as dc x by, this will be equal to dc by we are calling as it as theta. The HRT we are calling as theta, and it will be equal to rate of formation minus rate of loss. So now if we integrate if we integrate it with, like, we can go for integration where we varying the concentration with respect to time from 0 to HRT theta equal to here RF, and because there is no formation, we are not looking for the formation of particular compound, so RF value will become 0, and we will only have RL. We will link varying from 0 to theta. We solve this, we will get theta minus C0 zero reaction, so we can write this as theta minus 0. Oh, wait, wait. This part is wrong actually. Here we have concentration, so we need to take this concentration here. So there will be logarithm here. VDC. When we replace RL with the reaction constant K and C, so the concentration will come in here. So we have to integrate this 0 to theta equal to integration of 0 to theta minus kt theta. If we integrate this term, we will get ln of C, which is varying from 0 to theta equal to minus k theta. this will be ln of p theta minus ln of c naught equal to minus p theta. And this, if we negative bring here, it will be ln of c naught. Ln of c naught divided by c theta. Or we can just take it like this only. Ln of p theta divided by c naught. If we take this ln on the other side, it will become exponent. It will be e की power minus a theta. This is formula. We can use this formula in this problem directly. We have given the target concentration. So target concentration will mean the concentration of the contaminant in water at the end of HRT. So if we provide PRV, at the end of PRV, should be some concentration which we require, which is acceptable to us as per standard. So that value is given. So we are given with C theta value, concentration at theta time. So this is given as 3.5 into 10 to the power minus 3 milligrams per liter. And initial at the maximum concentration found, the initial concentration you can consider it as like before the
Is -6, no?
yeah, I have taken it in milligram because
Okay.
here initial value is given in milligram. So at
ठीक है.
the inlet of the PBR we have C naught, and at the outlet of the PBR we have C theta, and we're taking T time to cross this PRB. So C naught value is given 5 milligram. So we can just directly put values if we can use this formula. So C naught value will be 3.5 into 10 to the power minus 3 milligrams per liter, and it will be C naught is 5 milligrams per liter, and it's be equal to e की power minus k value is given in the question, which is 0.14. Rate constant is given 0.14 R inverse. So 0.14 per hour into theta. If we solve this, theta value we will get. Can you calculate the theta value for this? It will be around 51.88 hours. In this question, this the retention time required in PRB for the same influent and remediate water concentration is HRT was asked, so this will be the value for HRT. Now, is there like in any issue with derivation or solution you didn't understand?
No, sir.
Like is it clear or
It's clear.
okay? मैं आपको आवाज नहीं आ रहा है।
मेरा को भी क्लियर है.
जो
I just wonder, this is the first order rate reaction, isn't it?
yeah
This
yeah
E
yeah
theta by C meter.
yeah
So
yes
why we did not directly write it? I mean, we could have,
we
because
could have
already it is mentioned that, yeah, it is for pseudo first order rate reaction, right?
yeah we could
They
have
all,
directly wrote it, but in class sir explained the whole derivation. That's why I
acha, acha,
went
acha,
for the
acha.
whole
Okay.
derivation. And most of the
No, no,
time
it
it
is
is
useful. Yeah. I just wondered that, okay, right, right.
yeah.
Okay, right.
Like and in environmental engineering we also study the first like the order of reaction and those chemical formulas, but normally we don't use them that much. So direct
Okay,
derivation, yeah.
okay.
The next question is the use of PRB's advantages over other methods as treatment can occur within
Mm,
built-up area and
mm.
no day-to-day attention is required.
True.
Yeah. So this was the conceptual model which was sir was discussing in the class where three different mechanisms are happening and they can happen individually or simultaneously as we see in have seen in the case of uranium. So this is based on the similar concept you can try to answer.
So this can be used for metal ions whose reduction potential is higher than that of iron, like which has more tendency to get reduced, exist in reduced state than iron, because zero valent iron will be oxidized.
Should I
Yeah, so
2
the
plus
other
2
metal
is
should get reduced.
yeah.
So that means their reduction potential should be higher than that of iron.
Okay.
So zinc has a tendency to exist in plus two state. So probably this may not be true.
The first statement.
Yeah, it may not be true. I mean, think this may be false. The conceptual model removal of using this condition is.
Like these three
Oh,
situations are
okay,
there.
yeah, I
Your
got it,
your
got it,
logic
got it.
your logic applies to the B and C part.
Yeah, yeah, yeah. Hmm. So that's the option.
So what do you think which option will be the correct answer?
I think the three option three is option only, option and
Yeah,
reduction only.
yeah,
Yeah, right.
yeah. The same logic which you said which applies on B and C, and the
Yeah.
contrary of that logic, because of that only reduction won't happen. So option will be
Yes.
the primary mechanism.
Yes. Match the following.
This is basically what type of PRB we should use based on what we want to achieve. Like if we want to, if water is acidified, what we want to like, we want to control the pH. So what material we should use in that sense.
So one bit B certainly acidified water limestone 2A. So 1D, 2A, 3B, 4C.
Yeah, acidified water. C will be D, RSB, mixture of oxidized and reduced organics. So, C,
Hydrocarbons definitely with biological agent and
yeah,
acidified will be with limestone.
limestone. Yeah. So this. Yeah. This is the answer. I have few more problems, but do you want to ask any like doubt which like in the week 4 you had?
We also have a session tomorrow. Can I, tomorrow I will go through the things tonight and
Okay. There's one more session tomorrow. Yeah. I
yeah.
no, yeah, for the problem session only. I think he will discuss the similar problems. Uh,
Okay. Okay.
uh,
Okay.
if you want to like
For
attend any.
whatever you taught us today, it is clear to me. Yeah.
Okay. So did you had any other like problem in week 4 or week 3?
No, week three is now clear. I had doubt only about why we are using PABL density, why
NABL,
it was required. NABL, yeah, NAPL. So that was not clear to me. Now I am clear about it.
okay. Okay, ma'am. Uh, for today's session, like these are the questions I have.
Right, thank you. So we are logging off now? Yeah,
Yeah, yeah, you can log out.
right. Thank you so much.
Thank
Thank you, sir.
you. Nirupa, you have any doubt?
No, sir.
Did you attend the video lectures which is given by sir week till week 4?
Actually, half of that I have listened, sir. I have some two more sessions I have to listen.
For week
Uh,
4?
yeah, yes, sir.
Okay. So did you have like any doubt in this session or previous week 3, week 2?
No, sir.
Okay.
Okay.
Mm,
Thank you, sir.
thank you. So in this problem, a tube to be radiated by PRB is 100 meter long. So dimension is given and porosity of aquifer is given. Scalar value in the batch reactor is given. Concentration of ZVI in batch reactor is given. These values are basically for lab setting, and we have to implement this on the site also. So for site, we have to calculate the rate constant in this problem. So mixture porosity is given, bulk density is given. So from there we can, we're aware of this equation. We can apply this equation for both the scenarios where we can take it as R for lab scenario will be equal to K C concentration of ZVI in lab scenario to specific surface area, and so into C. So from this we can derive that K K KL for lab scenario is equal to basically, we can also write in this way ZVI for lab into, yes. Similar we can write for K value for PRV or site. you can consider it as site ks is equal to k concentration of ZVI for site and specific surface area. So if we take first and this is second, the ratio of first and second, Ks upon Kl equal to K CZVI for site and As divided by K ZVI for lab specific surface area. As value will cancel out. So this will be the equation for the ratio. So we can write it as K for site divided by K for lab ratio concentration of ZVI ZVI for site divided by C ZVI for lab, which implies that K for site will be equal to KL P site divided by C for lab for ZVI. We can calculate K's value, but we are not given, we don't know, we know the KL value. KL value is given in the problem. This is the KL value. We also have ZVI concentration, C ZVI lab. We need to calculate Ks value, and still we don't have C ZVI for site. So this value we can calculate from the information which is given here. This. So if we calculate CS or C ZBY for side, it will be equal to mass of ZBA divided by volume. Volume of water, volume of water this could be further written as mass of ZVI. We can calculate from the proportion values which are given here. So it is around 20%. The ZVI is around 20% of the sand. Calculate volume of water. It will be around. So this value will basically come out from fraction of ZVI into density divided by velocity. How did we get this value? We can understand as so. To understand where did we get this formula, density of soil. So it's just a simple calculation that if you want to calculate the mass of NZVI, it is given that it will be 20% of the total soil we are taking. So we can directly write it as 0.002 or 20% into total mass of soil. Soil divided by, and volume of water we can take it as, volume of water will be porosity into total volume, right? So porosity into total volume. Now the mass of soil can be replaced as, I take it, I explain it here. Mass of soil can be taken as 0.2, which is a fraction. Mass of soil we can write directly, density is equal to mass by volume. So in place of mass we can write density into volume, density of soil into total volume divided by porosity into total volume. So volume will cancel out, and this will be the formula, fraction into density by porosity, which is written here, which is also written here. So now if we put values directly into this formula, let's go to the next slide. If we calculate C ZVI for site will be 0.2, which is the fraction of ZVI into density of soil is given to us as 2900, which is given in the question as 2900 here, and porosity of the mixture is given as 0.35. If we calculate this value, this value comes out to be around 1657 plus 0.14 grams per liter. So once we know the concentration for ZVI at site, we can now use this formula which we derive here, right? If we take directly, now we can calculate the rate constant for pseudophosphoric reaction, Ks equal to, at site will equal to rate constant at lab into concentration at site for NZVI to concentration at lab for ZVI. So this will be equal to, if we go further to the question, the Ks value is given as, Kl value is given as rate constant for lab situation is 0.02 hours, 0.02 into Cs value of this, which we calculated. So this will be 1, 6, 5, 7, 1, 4 divided by Cl value, which is given as 125 grams per liter, if we solve this, this comes out to be 0.02 into 13.257. If we further multiply, the value comes out to be 0.265. RMS. Second part of the problem, which is asking for the calculation of thickness of PRB. So during the class, we were given one formula for thickness of PRB calculation where HRT was equal to porosity into area of the PRB into thickness of the PRB divided by flow rate. So Q value is given as 50 hours. Velocity is 0.35. Area, you can calculate from the values given here. So area will be this is the box. This is the depth. This is the length. This is the depth. This is the length, and this is the width. So area will be equal to 6 into 28. if I want to calculate for t, the value will be t equal to q, which is 50 hours. 50 hours, we have to divide it into years. 50 hours divided by 24, convert into days, into 365, convert into years, into 25 meters, which is 25 meter per year. And this will be also here, divided by velocity will be 0.35. Here 28.6 should be around